Hey, Algebra 2, welcome to week 8, the final week of distance learning. This being the last week, we decided we wanted you to learn something new and something that is going to be very key into whatever math class you take next year, and that is going to be adding and subtracting rational expressions. So to add and subtract rational expressions, we need to be able to also add and subtract fractions, because that's what they are. Rational expressions are fractions. They are just made up of a polynomial in the numerator and or the denominator. So there's going to be x's involved. Remember, when we add and subtract fractions, we want the denominators to be the same. So here, if I have 1/5 plus 3/5, their denominator is already both 5. So all we are able to do is do the 1 plus 3. It simplifies to 4/5. Okay. Same thing with subtraction. 6/7 minus 4/7. Their denominators are already the same, which is 7. So that doesn't change. Once the denominator becomes the same, it stays. And then you can focus on just your numerator. So 6 minus 4 gives us 2. Okay. Same thing when we have rational expressions. That's what this is here. Notice we have variables. These numerators and denominators are being made up of a binomial. Okay. So if I look here at my denominator, x plus 4, they're already the same. Okay, so because they're already the same, I can go ahead and just add like terms on the top. So see, there's an x plus x, and then I also see minus 3 minus 2. If I combine like terms, x plus x gives me 2x, and then negative 3 minus 2 gives me negative 5. We're over x plus 4. There is nothing else to simplify. A lot of you might want to try to take that x away. Remember, you cannot do that because these are binomials. They're attached to something else. That x at the top also has a minus 5 attached to it. That x on the bottom also has a plus 4. So because it's part of a binomial, we cannot just take away our x's out of the middle of it. Okay, they have to be standing by themselves. The second part to these problems is going to be asking you to find any x values that makes it undefined. Well, what would make a fraction undefined? If the denominator was 0. So what x value would make x plus 4 equal to 0? Subtract my 4 over. All right, if x was negative 4, that would make it 0. So that's what's undefined. So x is not allowed to be negative 4. Okay? So that's what we can do when they are like denominators, but of course that's not always the case. So if we have different denominators that are polynomials, we're going to need to be able to remember how to factor, and then we're going to pick all of our different factors and they become the common denominator together. Okay, like right here on example number 2, x squared minus 81, that's a difference of squares that we can factor into x plus 9 and x minus 9. And then our other factor is just x minus 9. So what are all the different pieces? Okay, well, I see an x plus 9, so that's one of my factors. And notice they share x minus 9. So that's the other factor. This would be the least common denominator for that problem. They had to have each piece of my factors. All right, example number 3, we're going to have to factor both of these pieces. So x squared minus 2x minus 3, so we think what multiplies to give me negative 3 and adds to give me negative 2. So that's going to end up being x minus 3 and x plus 1. My other one is the x squared minus x minus 6. Factor this if we can, which it is possible. Multiply to give us negative 6, add to give us negative 1. That is going to be x minus 3 and x plus 2. All right, so we're looking for all the different factors to get put together. Okay, I see in here they both share x minus 3, so that's one of them. This piece has the x plus 1. That needs to be included. This piece has an x plus 2. that needs to be included. So all the different factor pieces get brought together to be your common denominator or your least common multiple for your denominators when we're adding and subtracting. Okay, so how do we bring in missing pieces? Well, let's look at a typical fraction first without any variables. If I asked you to do 2 over 6 plus 3 over 10, to add these together, you would make their denominators match. Okay, so what least common multiple can we get from 6 and 10? Think about it. The number that comes to my head is 30, right? So if I did 6 times 5, that would give me 30, right? If I do it to one part of my fraction, though, I have to do it to the other part of my fraction. So that piece becomes 10 over 30. All right? Over here, to make 10 30, we're going to multiply it by 3. Again, I do it to one piece, I got to do it to the other. So my second fraction, still positive, 3 times 3 is 9, 10 times 3 is 30. Look at that, now my denominators match. I can add my numerators to get 19 over 30. Okay. And when it comes to, like up here, it asks for what x values would make it undefined. There is no x value in the denominator, so here x could be any real number. So there's no restrictions for this one for your x. So that's why it's not being listed. Okay. Here's an example before we do one ourselves. So the steps when you have different denominators, okay? The example given here is 1 over x plus 2 over x squared minus x. The first thing we have to do is we have to factor each denominator, okay, of each fraction. X just stays x, but x squared minus x, you can factor out an x, so it becomes x times x minus 1. So see how they both share an x, so that is included in our least common denominator. And then this piece had the x minus 1, so that's the other piece. So our least common denominator is x minus 1. The second fraction has both pieces. My first fraction had the x down in the denominator, but not the x minus 1. So you had to multiply each piece to the by x minus 1. Because now when you do that, when you bring in that missing piece, now my denominators are the same. All right, we multiply my numerator, 1 times x minus 1 plus 2. So 1 times x minus 1 is just x minus 1. And then plus 2 gives us an x plus 1 over x minus 1. You can leave it like this, or you can bring it together. It's up to you. I like this piece because I can easily see what x is not allowed to be equal to. So here the x values we couldn't have. See how there's two x's? So there's two values x can't equal. This x by itself cannot equal 0. And then x minus 1 cannot equal 0. Add that 1 over. So my two restricted values, x could not be equal to 0 or 1. Anything else, this rational expression would be just fine. All right, let's do one. Here we go. Adding, we have x minus 3 over x squared plus 3x minus 4 plus 2x over x plus 4. Remember, step 1 is to factor the denominators. Okay, so when I go to factor my denominator, like this guy right here, multiplies to give me negative 4, adds to give me a positive 3. That becomes x plus 4 and x minus 1. Once you factor it, you can kind of cross that out because you don't need it anymore. Okay, now look, both denominators have an x plus 4, but what's missing? This first one has an x minus 1. This does not have the x minus 1, so that's the piece that's missing. If I multiply it to my denominator, we have to multiply it to our numerator also. So notice this step, once you add what's missing, here you should have a common denominator. They both have x plus 4, they both have x minus 1. All right, since my first piece wasn't missing anything, we're not going to change that numerator. X minus 3 is still x minus 3. Nothing was multiplied to it. My second one, though, got multiplied. So 2x times x is going to give me a positive 2x squared. And then 2x times negative 1 gives me minus 2x. All right, over our common denominator, which is x plus 4 and x minus 1. Remember, once the denominator is the same, there's no changing it. It will always be x minus 4, x minus 1, or x plus 4, excuse me. Here we need to simplify our numerator. So I see some like terms. 2x squared, that stays. It's going to come first because we're going to do standard form. I do see x and then minus 2x. That's going to give me negative 1x, or minus x. And then we have minus 3 all over x plus 4 and x minus 1. All right. I'm not going to get ahead of myself. Okay, so this is simplified. We're good to go. And we cannot forget to list any values for which the expression is undefined. So what would make each piece of this 0? Well, here, x is not allowed to be negative 4 because negative 4 plus 4 is 0, which would make this whole denominator 0. And then here, x is not allowed to be equal to positive 1 because 1 minus 0 is 0. And so if either one of these are 0, the whole denominator becomes 0 because we're multiplying, which would make the whole thing undefined. Okay, so these they have two parts as an answer, your simplified expression and the pieces that are going to make it undefined. All right, let's do another adding one. And this one has a fun extra step at the end that I enjoy. I hope you enjoy it also. Everything else to start it off, though, is the same. We need to factor our denominators. X plus 2 cannot be factored anymore. X squared minus 4, though, there's our difference of squares again. You'll notice that happens a bit because we like it. Difference of squares, that means it's going to be x plus 2 and x minus 2. So I've factored it, don't need that anymore. All right, so let's see what they have in common. They both have an x plus 2, but my first fraction is missing the x minus 2. So that's the missing piece. So we need to multiply my first fraction, numerator and denominator, by x minus 2. Now their denominators match. All right, let's multiply. X times x will give me x squared. X times negative 2 gives me minus 2x. We did not multiply the second fraction by anything, so this is going to stay. Plus negative 8 is just going to be minus 8. And our common denominator is going to be x plus 2 and x minus 2. Okay, so here, I'm going to go ahead and list my restricted values. So what pieces could x not equal? Well, it's always going to come from your common denominator. So here, x is not allowed to be equal to negative 2 or positive 2, because that would make them 0. But what I do notice, and this is the fun part, I can actually factor my numerator here. I could factor that to be x minus 4 and x plus 2. See that? Because negative 4 plus 2 is negative 8, and negative 4 plus 2 is negative 2. So I can actually factor my numerator here. And do you see what happens? They both share a common factor of x plus 2. So here we can cancel them out because the whole thing is the same. The whole binomial matches. So our final answer for this problem is actually going to be x minus 4 over x minus 2. And again, you cannot simplify. The x's cannot go away. 4 over 2 cannot simplify because they are attached as a whole binomial. The x plus 2's were canceled out because it was the entire binomial that matched. Okay? Here, the entire binomials, x minus 4, x minus 2, are not the same, so that is done. This also shows why it's important to do your restricted values before you simplify if you can, because here, see how x plus 2 eventually got canceled out, but negative 2 is still going to be a restricted value. Okay, because if we had that, it wouldn't work along the way. All right, so this is our final answer. All right, two more examples, and they are both going to be subtraction. It is almost the exact same steps. The only thing that is different, okay, I'm going to change the color. Let's make it orange. Okay, the only thing that is different with subtraction. Think about when we subtracted polynomials. What was always the first thing we did? Think about it. I bet you said distribute the negative. It is the same case here with our rationals. Okay, so when I see a minus, the first thing I always do, I change it to a plus and I bring that negative up to the top. Okay, let's pretend real quick. Let's say it was 2 plus x up here. Okay, when you distribute the negative for this, so change it to a plus, you would distribute the negative to both pieces. So this would become negative 2 and then minus x. So when you distribute the negative, make sure you distribute that piece to every piece in the numerator, not just the first one. Okay, it changes all the signs in the second numerator. All right, so let's do this one. I have distributed my negative sign, so that's good to go. My next step is supposed to be to factor. Well, I cannot factor either one of these. They're already as simplified as I can get. Okay, so here my denominator is 2x plus 5. Second denominator is 5x minus 2. Okay, so both denominators are missing the other denominator. So to make them be the same, we're going to bring in each other's missing pieces. So my first rational expression is missing the 5x minus 2. Okay, and my second rational expression already has 5x minus 2, but it's missing the 2x plus 5. All right. So here, no factoring, nothing in common. You multiply each rational expression by the opposite denominator. Okay, this happens sometimes. So here, we're going to have to FOIL. So multiply 5x minus 2 and 3x minus 2 by distribution. We're going to get 15x squared minus 10x minus 6x plus 4. So I did 5x times 3x. Then I did 5x times negative 2. Then I did negative 2 times 3x. Then negative 2 times negative 2. All right, I'm going to distribute the other side. So remember, this is now negative 2 times 2x, which is going to give me a negative 4x. And then negative 2 times 5, which gives me negative 10. All over our common denominator. Whoop, don't know what just happened, sorry. All over our common denominator, which is going to be 5x minus 2 and 5x, oops, I'm sorry, and 2x plus 5. Okay. All right, let's simplify and combine like terms our numerator. So what do we have? I only have one x squared, so 15x squared is still going to lead it. My x's, let's see here, negative 10x, negative 6x, and negative 4x give me negative 20x. And then I have 4 minus 10, which combines to give me negative 6. All over our common denominator of 5x minus 2 and 2x plus 5. Okay. And this this numerator, it cannot be factored. It almost looked like you could take a 3 out of it, except that 20 is not going to work. You can't distribute a 5 out of it because of that 6. So yeah, this numerator is as simplified as it's going to get. That's our final answer for our simplifying. And then we still have to do our restrictions. So remember, each of these pieces cannot be equal to 0. So 5x minus 2 cannot be 0. So if we simplify here, we're going to get x cannot be 2 over 5. And then my other piece, 2x plus 5 also can't be 0. So when we simplify here, we get x cannot be 5 over 2. So my restricted values, x is not allowed to be equal to positive 2/5 or negative 5/2. All right, make sure you always include that. And yes, it is in the directions, but do not forget, you make sure you need to tell me what's going to make your expression undefined. All right, here we go. Last one. Number 7. We have x over 2x plus 6 minus 6 over x squared plus 3. All right, I see a subtraction. So the first thing I am going to do is I'm going to distribute that to all the pieces in the numerator. In this case, it's only a 6, so I'm only going to distribute my negative to the 6. All right, next piece is I have to factor my denominators. Excuse me. 2x plus 6, I can factor it. I can actually factor out a common, the greatest common factor, which is a 2. So this is 2 times x plus 3. All right, and then my other denominator, what do we have? X squared plus 3x. This one I can actually factor out an x. So it becomes x times x plus 3. All right, so what are all the different factors? It is 2, x plus 3, x plus 3. Notice they both already have the x plus 3. My first piece is missing an x. My second piece is missing a 2. Okay, remember you're trying to bring in the missing piece to make them exactly the same. So my first piece, this is missing the x, which is going to give us x squared. My second piece, my second rational expression, is missing the 2. So negative 6 times 2 gives me negative 12. So look at my denominators. By doing that, both denominators have a 2, they have an x, and they have an x plus 3. They are the exact same. Okay. Order, I know my orders are not the same, but remember we're multiplying. So because of that, order does not matter. Okay. Let's see here. X squared minus 12, that cannot be factored. It's not a difference of squares because 12 is not a perfect square. So that's as far as my numerator can go. I'm not done though. I still need to be able to identify my excluded values, or what's going to make my denominator equal to 0. There's 2 different x's, so there's going to be 2 different values that I cannot have. So 2x is not allowed to be equal to 0. Divide by 2. Here we have x can't be 0. And my other piece is x plus 3. So 2 different factors, 2 different values. X plus 3 cannot be 0. Subtract that 3 over. X cannot be negative 3. So my excluded values are 0 and negative 3. So this expression works for any x value possible as long as it's not 0 or negative 3. Okay. In your assignment, please do not forget your excluded values. That is half of your answer. And factor things as low as you can to see if you can cancel out any common terms like we did in example number 5. That happens sometimes, not all the times. Obviously, in all of our examples, it only happen once. But it's just something that you can always check. All right? So if you have any questions, this is a brand new topic. So obviously, we are here for you. If you have questions along the way, reach out to us. We will help you. Zoom this week. If your teacher does a Zoom, I would definitely recommend being present at the Zoom this week so you can get any other clarifications from your teacher. All right. Thank you, guys. And we'll let you know what you're going to do during our last week for week 9. All right. Have a good one.